So my name's Ashesh. Thanks very much for hanging around, staying. I did tell Harry that the next time we do this, we should serve beers to sort of get more people to hang around. So Harry, that's actually something the English would support, I'm guessing. Matt Hicks is next. Matt's definitely funnier than I am. Matt runs engineering for OpenShift and management and developer and a lot of other stuff. So he'll come and talk some more, and then we'll, of course, have David from Google. So I don't have jokes, but I have questions. So let me run through some questions for you. Question is, what is OpenShift? So you'll be like, strange question. Why ask that? Well, that's because we seem to be a lot of different things to a lot of different folks. A, is it a container-based cloud application platform? That sounds like a mouthful. That you can deploy on physical, virtual, private, public clouds? Possibly. Does it support, we had Rachel talk about this, and I guess Harry and the rest of the folks, they've been talking about these microservice-based architectures, enabling middleware services to run on them. Can it be consumed as a public or dedicated cloud service or privately administered and managed by folks in your organization? Is it a PaaS? Is it a CaaS? It's like a Superman movie now. Can it be used by developers, by enterprises? Or E, is it all the above? So obviously the answer is all the above, right? It's being used as a platform as a service. Lots of folks have been talking about what CaaS is, a container as a service. We've had developers use this at scale. I'll talk about that as well. And large customers all around the world. I've listed some, but if you are sticking around for Red Hat Summit over the next few days, I encourage you to go visit. A lot of these customers are here talking about their use of OpenShift, as well as other customers, right, like Airbus or Swiss Rail and what they've been kind of doing with it. So definitely go check out their use cases. But like I said, right, let's talk about progress, right? So from a developer perspective, we've had over 3.1 million apps deployed on the platform since we've had OpenShift around. So that's since 2011. Adding lots of users every week, right? So over 6,000 users being signed up. Got a couple thousand new applications landing on the platform every day, and over 4 billion requests a day that we serve out. Also really proud about OpenShift Commons, which is our essentially free-to-join community for folks who want to share best practices about deploying containers, running containers at scale, learning about the best practices around developing and deploying and managing a platform as a service offering, and really all kinds of organizations, users, developers, enterprises, not-for-profit, universities have joined OpenShift Commons. So encourage you to go check that out and sign up for that if that makes sense for you. So why are we here talking about all this, right? So Harry said, hey, look, we've started this conversation today talking about developers. We've gone to talk about DevOps. We'll spend a little bit more time talking about DevOps and Ops and really some best practices around how you think about application development and deployment, but also about how you manage your processes and run and manage infrastructure you have. OpenShift around 2014 had been adopted pretty significantly, had lots of traction with customers and users, and our version 2 technology at that time was being well perceived, but the space was fragmented. By that, I mean if you want to extend out the platform and run software on it, right, you had to essentially do something called build cartridges for OpenShift. And then there were build packs, and then there was Amazon Machine Images for the AWS platform, and so on and so forth, right? So the space was fragmented. When people wanted to use software, they had to package it up in different ways to use it and leverage it. And then, of course, as you go cross-platform, that breaks. Docker had been out for a few months, right? And we kind of see the promise around that. And we said, well, this is an opportunity for us to converge on a single container format and a runtime around that. But once we did that, the next question was, well, how do we manage these containers at scale, right? How do we manage the clustering that happens around with this? How do we manage the health of these containers that we run across different environments? And that's where really Kubernetes came in, right? So that's kind of the part of the journey that we've been on, about thinking about if we want to run these, manage these, be able to manage state, be able to figure out if we're going to put this in our own data centers or run this in a private or public cloud, or what people call hybrid clouds. Right, we've got to be able to solve this problem and be able to solve this at pretty large scale, and then be able to continually increment upon that. Now, of course, it's hard to do that on our own, right? And obviously, it's difficult to do that if you don't have a community around you. And so us thinking about participating in a wider community, right? So if you're a user or a customer, you don't feel like you're locked into a single vendor solution. It's really important. participating with several other organizations adopting the Docker technology as part of the Open Container Initiative, is something that we stand by. We invest a lot of our time and energy and our engineering resources to help drive forward. The same is the case with the Kubernetes community, and we'll talk a little bit more about what that means for us, and obviously investing in the Cloud Native Computing Foundation. It's not just us, right? It's a lot of other companies, right? So definitely Red Hat, right? But it's also, Cisco and Intel and IBM and Huawei, and of course, Google that's been leading the charge around this. But to tell you a little bit more about the journey we've been on, I want to bring up Matt Hicks.
Thanks, Ashesh. So this was a pretty good spot to be in, right? We had the industry adoption. A lot of people have probably heard about this technology. But I think one of the most important parts is actually to look at the problem that Kubernetes was there to solve. When you look at container orchestration, we really had to shift into this mindset of how are you going to describe either a modern day application or one of the thousands of applications that you're running today. And Kubernetes introduced these building blocks, things like pods to describe container colocation, and services to take a bunch of those pods and describe how are you going to access them at a network level, or replication controllers to describe how many instances of those you wanted and how scaling was going to work. Really gave us that language, that vocabulary, where we could take this great, very exciting concept about containers, start stitching them together to actually form applications. And if that was Kubernetes 1.0, which we were really excited about, the best part is the pace of the project and capabilities has continued to increase. If you look at the last release, Kubernetes 1.2, which is what OpenShift today is based on, you saw a humongous increase in scale and capabilities. You saw application configuration greatly improve, which meant more applications you could actually represent in this model. Then you saw things like the new scheduling features and extended schedulers, which meant different workloads closer to Mesos or batch-like patterns that you could run. So the project didn't only give us a great foundation to work with, but it has been increasing and innovating at a tremendous pace. So with this combination of stuff, we now had the pieces that we could build the next generation of OpenShift on. We had the runtime, we had the container format, we had container orchestration. That got us back into our sweet spot. We started to get into those areas of how do we now give prescriptive patterns on building continuous integration and continuous deployment around Jenkins workflows and being able to establish those pipelines. Then when we talk about deployment, how do we make people not resolve the same problem for the 1,000th time and give them blue-green style deployments or canary deployments or even A/B deployments where you can split network traffic on them? Then you go one level up and say, all of my developers don't want to understand how to build layered containers right. How do we build in that automation and bring that all the way to the developer tooling? And then lastly, when you're running this at scale, how do we give you operational management where you can't just view the container layer, but you can link that to your VMs and you can link that every step down to the physical hardware? So that to us really gave us this vision around our container platform. That's where we started in OpenShift 3.0. We've continued to advance as we go forward. When we talk about something like OpenShift, it's not just integrating this technology. We work differently. We really get involved in the communities themselves. So if you look, great examples with Kubernetes. One of our needs, Ashesh mentioned OpenShift Online and running millions of applications. Multi-tenancy was pretty important for us. We had to be able to separate customers from each other, both in a functional area as well as the resources that they got. This work allowed us to drive capabilities upstream in Kubernetes like the namespace capabilities as well as quotas and limits. But then we also looked to our enterprise customers who they were running applications, stateful applications against storage that they had on-prem today. That let us help drive the volume functionality and implement storage plugins ranging from NFS and iSCSI and Fiber Channel all the way to new Ceph cluster and even cloud-based storage. But most of you probably know, this is how Red Hat works. This is what we do. We are also able to extend this model to our customers. Probably one of my favorite things about being at Red Hat. Now, Amadeus has been a great use case of this because Amadeus last year, when we announced OpenShift 3.0, they announced they were betting on the OpenShift 3 platform, right when we first started talking about it. And the reason was they had been working with us upstream in these communities before we'd even GA'd the product. That collaboration led to capabilities like job support in Kubernetes. This is forming the basis of scheduling and eventually batch and Mesos-like workloads in Kubernetes that started with our first requirements with Amadeus. OpenShift and OpenStack, they're a huge OpenStack customer. They run OpenShift on top of it. They didn't just take the products and the integration we provided. They continued to improve that and actually became one of our primary contributors to the installation and integration we carry there. And then lastly, if you look at some capabilities like syscontrol, not sure how many people know about this functionality, but you're a C++ developer and you use shared memory. At the time, running a C++ application in Kubernetes, that was a little bit bleeding edge. There weren't a ton of people doing that. And Amadeus had that requirement. We worked with them for over a year to build this into all the various layers in the stack. When we were done, huge benefit to Amadeus, because now they have their application they could run in this model. But then it also ended up being a huge benefit to all the other communities and a really, really exciting feature. So this was a neat way where we were able to take our model, our way of working in the open and open innovation, and extend that to our customers as well. But before people knew about Kubernetes, and we were talking about this and all excited about it, it really started as a bet for us. Back in history, this was sort of our gamble. When we knew we were going to bet on Docker and we were having this conversation of what should we do in the orchestration space, a great technical partner of ours, Google, had this idea. They were going to take a lot of their knowledge, because they'd been running on containers for a long time, and they were going to open source that project, and they really wanted us involved from the beginning and to bet the next generation of our platform on that technology. And now looking back, I'm extremely happy we made that gamble, but it's not just because the technology is great, but I think Google has built a world-class open source project and ecosystem around this as well. To talk with you a little bit more about that, I'd like to introduce David Aronchik, who runs product management for Kubernetes from Google. David?
Thank you. Thank you very much. Thank you for the opportunity to come and talk. So it's interesting because we at Google, when we first got this going, had to make almost the exact same bet, but in reverse. When you're starting a project like this, the first people that you bring into the project are some of the most critical. They're the ones who help architect, who set the culture, who set the mentality for how you're going to go about this project, what's in, what's out, so on and so forth. And while we're in the midst of sorting through that, we're also moving a million miles an hour, checking in massive blocks of code and things like that. One of the best earliest signals we saw when we were building Kubernetes was senior Red Hat engineers pointing out, Go hygiene mistakes that we were making. These were people who actually cared, not just about the project as a whole, that we were getting the right features in, but that we were also building something that would be maintained over its entire lifetime. Now, they haven't just gone forward and made sure that we indented properly. They actually had, they continue to add core features to the product and make huge improvements, whether or not it's fundamental things like persistent disk. We already talked about jobs. Some of the Red Hat engineers were some of the ones that will be invested in huge features coming up around improved support for stateful services. So it was a big bet at the beginning, but I think unequivocally we can say we made the right one. As far as the Kubernetes project as a whole is concerned, for those that don't know, it is obviously an open source production-grade orchestration system, built in the same way that Google does it internally. One of the most fundamental goals about Kubernetes is the ability to run anywhere. So it's not just a Google project. It runs on bare metal, on VMware, on Vagrant, on AWS, on DigitalOcean, on Azure, you name it. And most importantly, it allows people to deploy it in the places that make sense for them, where you can now run additionally things on top of it, such as OpenShift. So basically, our goal is to have this very clean platform that lets other people go off and build huge businesses on top of it, exactly as Red Hat has done. We have broad industry support. We already talked a lot about that. Red Hat is certainly a leader here. And as a whole, we've counted up over 233 person-years worth of contribution, and that is in just 12 months since we GA'd. Actually, technically 2 years since the first check-in. But very, very young project to have that much momentum behind it. In the coming days, we will be announcing Kubernetes 1.3, again with enormous help from Red Hat and many, many others in the community. Here are just a few highlights. The first is around scaling. We've doubled the number of nodes supported on the Google Cloud. On premises, we see people going even higher, but with a 99.95 SLA on the Google Container Engine, we support twice as many nodes as we did it just 3 months ago. We've made massive improvements around stateful application support. One of the biggest problems that people have when approaching containers today is how you migrate in and manage things like state. Built in as first-class object is the new pet set object, which will help you manage state for things like databases, key value stores. We have a significantly improved local developer experience. So on your laptop, with one command, you can spin up a Kubernetes cluster and begin building and testing just like you would with any other container system. We have automated integrated cluster scaling. So Kubernetes will watch your cluster and see whether or not you have pods that need scheduling and go out and request more CPU. Or if you're not using that CPU anymore, it will naturally scale down as well, making sure you're staying within your efficiency and utilization guidelines. We have brand new support for container standards. One of the most fundamental things about open source is allowing people to choose. We'll be supporting Rocket, OCI, and CNI in the box. So you can choose the container system that makes sense for you. We have integrated support for cross-cluster federated services. Again, one of the most common things is people want to set up multiple clusters in multiple availability zones, bridge on-premises and cloud, and integrated into the box will be federated services so that without any additional work, you'll be able to deploy services and spread your load across those different clusters. And finally, thanks to Red Hat and some amazing work that they did, porting back work that was in OpenShift, we have a significantly improved identity and authentication management system in the box, allowing you to have greater control over the way that you interact with the cluster. So those are just a few of the things that are coming in Kubernetes 1.3 due out momentarily. And with that, let me pass that back.